Hi and welcome to another very exciting tutorial. Today we're going to create a pretty interesting game, so stay tuned for that. But before we get started, let's talk a little bit about WWDC 2016. Apple introduced a whole lot of great new APIs and frameworks like the new Siri API and apps within iMessage, for example. But in the last few years, I noticed that adoption of new features sometimes can be slow if you don't have good resources to learn about new possibilities within iOS. So this year, for the very first time, I'm organizing the Swift Tutorial Conference. It's an online conference, so you can participate from anywhere on the world, and it will take place in September. And as you can see, Swift Tutorial Conference is all about the features and frameworks that were introduced at WWDC. And all sessions are tutorial based, so you can directly integrate stuff that you've seen on the conference into your app. And the best of all, the Swift Tutorial Conference is absolutely free. So we have some great trainers. We will cover topics from around design. We will also have some basic sessions where you can learn more about iOS or watchOS or tvOS development if you're new to developing with the Apple frameworks. So there's something for everyone. And so as I said, registration and attendance to this conference is completely free. Just scroll down to the bottom of this page, which is swifttutorialconference.net. Click on the Register Now button, enter your email address and your name, and hit the Register button, and attend this conference completely for free. And you will also receive a discount of 50% of the Swift Tutorial Conference bundle, which will be available after the conference for just $99. So you will save $50 on that. And this bundle will include all the sessions that were recorded. It will include the complete source code of every project and some bonus material like written tutorials and stuff like that. So I hope you are as excited as I am, and please also tell me in the comments below if you have special suggestions for sessions at STC 16. I will update you on the progress of the conference within the next few weeks and months, so that you will always stay updated and know everything that is there to know about the conference. There's only one more thing I'd like to tell you about the conference, since we also have a call for papers. So if you yourself are interested in participating as a speaker, or you know someone who is, you can point him to this website. So just enter everything related to you and like your name, your email, and a topic and a description of that topic you'd like to present. And then we will decide if you can join Swift Tutorial Conference as a speaker. But let's now move on to our tutorial of today. But let's stay nevertheless at some WWDC related stuff, and especially this game, which won an Apple Design Award, which is pretty nice and also pretty addictive. And the most interesting thing about this game is that it features 3D touch. So this means that what it does is, depending on the strength of the pressure you put on the iPhone display, those two dots are increasing their space between them, and you have to put those circles through those holes and collect these little orange dots. So this is the original game, and I'd like to show you now what we are going to create. So I just brought up QuickTime, and we're now seeing a live feed from my iPhone, and this of course only works if you have an iPhone 6s or 6s Plus, because we need the 3D touch feature. So once I start a game, you can see this red square, and depending on how much I press the iPhone screen, I'm moving these two red squares around the obstacles that are in my way. So this is pretty much the same as the game that won the Apple Design Award, and I'm now letting it be, and we will write get started and bring up Xcode. So let me just minimize this. Let's close this. And let's fire up Xcode and create a new project. We will today create a game-based application. So let's select the game template here. Click next, and we simply call it Push Me. And we also have to make sure that we choose Sprite Kit as our game technology. And also we can only target the iPhone as a device because this is the only device that supports 3D touch. So let's click next and save that on the desktop, and I will make my window a little bigger. And now let's start with some preparations, like choosing the game scene right here. And the first thing we want to do here is actually give that another color. So let's choose a different color for our game scene. We will simply use black, like header text color or whatever, or we can also choose other color and define this as completely black here. All right, so now let's think about the gravity. We actually do not use the gravity or any other physics here in this game, so let's put this to 0 so that we don't have any gravity applied here. And let's have a look at the game scene.swift file. And what we can do here is, first of all, remove some of the code here. We won't use the touches began method, so let's clean that up a little, and then we're good to go. So let's now begin with adopting, first of all, an important protocol, which is the skphysics contact delegate. skphysics contact delegate, since we need to test if we are touching one of the obstacles with our players. And we actually have two players. These are the two red squares that you've seen earlier. So let's define them as properties here, which is an sprite node, and let's also have a player 2, which is also an sprite node. And then we will have an initial player position, and this is going to be a CG point. And that's actually all there is regarding to properties that our game scene class is going to have. Then let's in did move to view, and this function that is called immediately when our scene is drawn on the screen, we can call the physics world property of our scene, and again define the gravity as 0, and therefore we need to create a vector, since gravity is defined as a vector and we have no a 0 in x direction and also 0 in y direction. And then we will use again the physics world, so we can use self or just write physics world here, and assign the contact delegate to self. And then we are also actually ready to add our players and a lot of other stuff, but to keep our code organized, we'll create a new game scene extension for that. So let's create a new Cocoa Touch class. Let's call this game elements. Let's be a subclass of NSObject, doesn't matter really. And then we will simply remove the code here. Don't import UI kit, but let's import Sprite Kit here. And we will then write extension, and then it's an extension of game scene. And then we are good to go within the curly braces to define new methods and so on. So the first method that or the first function that we want to create is the add player function. And it does all the heavy lifting regarding the players and also creating the sprites and giving it some physical properties. And the first thing we want to do is actually creating a player. So we have an SK sprite node. We initialize it with a color and a size. So let's use UI color, red color. And you're, of course, completely free in choosing the colors as you like them. And then we will define a size for this sprite with a width and height of 50. So that is a square sprite node. And with that, let's give it a position, an initial position actually. Let's add the position using CG point and give it an x value of self.size.width and divide that by 2 so that it is centered. And also let's give it a Y property of 350. Then we will give our player a name, which is going to be player, so that we can identify it pretty easily later when we need to contact test with our player. And then, since our player does not react to the physics, we can use physics body, set its dynamic property to false, but we can still use contact test stuff here. So now let's give it a physics body, since we need that for contact test as well. So let's use the physics body property and create a new SK physics body. And this body should actually have a rectangular size that is the same as the SK sprite itself. So let's just use the player's size here. And now with that done, we actually reach the point where we need some category bit masks for our physics body. And to define them, let's go up here, and right before we start our extension, let's define a structure for those for this collision bit mask. So let's call this collision bit mask. And what we want to do here is a static constant for the player, which is a uint32, and then we will simply assign this bit mask, one for the player and one for the obstacle, also uint32, and this time we shift the bit once. And then we will also have, since we're here at the moment, you will have 2 enumerations, one for the obstacle type, which is going to be an int. And we have different kinds of obstacles. So the first one is small. Let's assign 0 here. We have a medium-sized one and we have a large one. So let's assign those values here. And we also have different row types. Let's also create an enumeration for that. We have one small obstacle. We have one medium obstacle. We have one large obstacle. And there's also a row with 2 small obstacles and one with 2 medium-sized obstacles, and the last one with 3 small-sized obstacles. And I should put in correct values here. So 1, 2, 0, 1, 2, 3, 4, 5. And with that, we have created all the structures and enumerations that we need, and we can go back to the definition of our players and assign a category bit mask now for the physics body of our player. So category bit mask, and this is going to be our collision bit mask, and this is going to be the player. Then we want to make sure that we also have a collision bit mask. So physics body collision bit mask, let's set this to 0. And then we have a contact test bit mask. So again, player physics body, and then the contact test bit mask. Now I get it right. Is of course with the collision bit mask dot obstacle, since this is what we are going to hit. And then we can actually just copy all that code here and paste it again right below. And then we will do the same thing for our player 2. It will receive the same color, the same size, the same position, and also the same name. It will also be not dynamic, so it's going to be static. It could have the rectangle size of the first player, but let's stay consistent here. And we also have the same collision test or contact test bit masks and so on as player 1. So we have 2 times the same code here. And then what we can do is we can add those 2 children. So let's add child player and add child player 2. And then what we can do is use our property with the initial player position and set and assign our player's position to that. All right, so let's move back to our game scene and call add player. And let's run the application. At the moment, we can still do that in the simulator. So let's give that a try. So this is how it looks. We have our black background. We have the players, or the one player that we can see at the moment, as a red square in somewhere here. But what we could think about is actually increasing the resolution of our game. So let's go back to our game scene and let's change the size to an HD resolution with 1080 in width and 1020 in height. And if we then run our application, everything should be a little smaller, and there we go. This looks pretty nice now. So let's think now about our obstacles, and let's move through the GameElements.swift file. Let me zoom in a little again and scroll down, and we will create some special new functions for the obstacles. I'm giving us some more space here so that we can see everything. And the first function that we're going to add is the add obstacle function, and the obstacles can have different types, and we're going to receive the obstacle type as a parameter here, and what we want to return is in Sprite Kit sprite node. And the first thing we obviously want to do is create an obstacle. So let's do that right here. This is an SK sprite node, and we will give it a color and a size. And the size is going to be white here in our case. Again, you could choose different colors if you like, and then we will choose a size for the obstacle. The width really doesn't matter at the moment, so we can set this to 0, but the height is going to be constant at 30, so we can set this right here. Then again, we will give our obstacle a name just as we did with our player, and we'll simply call it obstacle. And we will set obstacle and its dynamic physics body and its dynamic property to true. And then we will create different widths of our obstacle depending on the obstacle type that we received as a parameter here. And to get rid of that error, we can already return our obstacle. And this should remove it once I build it. Build succeeded. And now let's switch through the type. And we have different types here. So there is the type small, and we don't really need the default value here, but we can add a break already here. So let's just add all of the cases that are available within our enumeration. There is also medium, and there is going to be large. And so that we don't have to specify any specific pixels or the width in pixels, what we can do is define our obstacle and the size and its width by simply using percentages. So we will use self.size.width, and the small one is going to be 20% of our whole screen. The medium one is going to be 0.35, so 35%, and the large one will cover will cover 3/4 of the screen. So this is the way we actually define the different types of obstacles that we have already seen. So let's now apply this position to our obstacle by calling the position property and setting a new CG point with an X and a Y value. The X value, let's set this to 0, and the initial Y position is going to be self.size.height plus the obstacle size and its height. All right, and as you might have seen, we don't use the standard iOS coordinate system. The standard coordinate system begins in the top left corner, but in Sprite Kit, our coordinate system begins or has its is 0, 0 at the lower left corner. Because of that, what we need to do here is to put our obstacles outside of the screen right above the top border of our screen, we used complete screen height and add the height of our obstacle to this Y position. So this is going to be the position of our obstacle, and now we really use the size that we just defined by specifying our obstacle's physics body. So let's use the physics body, create an SK physics body object and assign it to it. And again, we will use the rectangle of size, and now we can use just the size of our obstacle to define the physics body here. And now we need to think about the collisions that we want to control. So again, we use the obstacle, the physics body, and as a category bit mask, we use collision bit mask, and of course the obstacle. And the obstacle and its physics body and the collision bit mask is going to be 0. So now we simply return our obstacle as we already did, and this actually gives us the obstacles in different sizes. And now we can think about how we really want a row to look like. So we have to think about different kinds of rows, and we already defined them here. So there is going to be rows where there's only one small, one medium, and one large obstacle, but there are also rows with 2 obstacles in small and medium size, and there is one row that will have 3 small sized rows in it. So there are different ways we could actually implement that kind of feature, or that kind of infinite scrolling game experience, whatever you want to call it. You could create a plist that would then have the positions already in it, and then we could use for loops to iterate through those plists and so on. But let's keep it simple for now. Let's simply create a function with an add row, which adds the rows, and we will have a type as a parameter. We already defined those row types, and then all we need to do for now is switch through those types again. And let's do this. So we have one small, we need to break every time here. We also do not need a default value, so let me do that here. So we have 6, I think. So 1, 2, 3, 4, 5, 6. We have one small, we have one medium, with one large, we have 2 small, we have 2 medium, and we have 3 small ones. And what's the problem here? There is no problem, so build succeeded. And now we can actually create all the obstacles that we need. For each case, we will create one obstacle. So let's call this obst. And then we will simply call the add obstacle function and tell it what kind of obstacle we want. We want a small one in that case. And then we simply have to use our obstacle and position it correctly. So we use CG point here. And this should be centered. So we use self size width, divide that by 2. And the Y position will simply be the obstacle's initial position. So let's set this to obst position Y. And then we can add our child obstacle. But at the moment, our obstacle doesn't really move down or does anything. So we need to add movement to every obstacle somehow. And therefore, we'll create our own function. We will call this add movement. And it will receive an obstacle as parameter, which is an SK Sprite node. And what we want to do is now create an array of Sprite Kit actions, move it down from the top to the bottom of the screen, and once it passes the lower edge of the screen, we want to remove it. So we will first of all create an action array, which is going to be an array of SK action objects. And then we will simply append the actions that we want to perform. So let's use the action array and append an SK action, which is going to be a move to action. We have to choose a position now, a location, a CG point, and the X position is our obstacle, and its position and its X value. And the Y position is going to be the negative height of our obstacle. So let's simply use the obstacle. Why don't I have code completion? But okay, obstacle size dot height, and let's choose an NS time interval of 3. All right, so now let's close all the parentheses here, and that should be doing it. Yes. Now action array append, and no, not append contents of, just append. Come on. Here it is, new element, and what we want to append is a simple action which is called remove from parent. So first of all, we will move our obstacle down, and once it reaches its destination, we will remove it from parent. And what we can do now is use our obstacle, run an action, and then we will use our sk action class and run a sequence of actions, which is our action array. All right, and now what we can do right before we add our obstacle to the screen, we can add movement to it, and we'll simply pass along the obstacle object. And we can actually give this a try right now in our game scene.swift file. And after we added player, we will simply add a row, which is going to be row type one small, I think. So let's see what happens. Run it in the simulator. And there we go. It runs smoothly down the screen. All right. So let's go back to our game elements. And we can actually do the same thing with the next two obstacle types, which is medium and large. We just have to choose different types here. So let me just copy that and paste it for the medium one and for the large one. And then for the add obstacle function, we will pass along medium one time and then also the large type one time. All right, so now we have still a few row types to go. We have two small ones in one row. So what we want to do is create two obstacles. So we have obstacle 1, which is going to be of type medium, and then we can copy that. We have the second obstacle, and then we will simply have to position it. So we use obstacle 1, its position parameter, its position property, use CG point, and then we give it an X position, and this is simply going to be the obstacle 1's width. Let me just allow that. So obstacle 1 size dot width, come on, and we will add 50 to that, and simply again the obstacle's position Y, and then we can copy that line of code, choose obstacle 2 here, and since we now need to think about the X position from the right edge of the screen, we have to use self.size .width and subtract our obstacles 2's size .width divided by 2, because the anchor of our obstacle is right in the center, and then we simply subtract 50 again. Then we can add movement to our obstacles 1 and 2. So let me just copy that again. And last but not least, we need to add our children again. So obstacle 1 and obstacle 2. All right, so this is what we need to do for our two small-sized obstacles in one row. And actually, we can simply copy this whole code again and put it in the next case for the medium one. And there we will simply choose yeah, this is medium actually. Oh, we already did that. So we have to change this to small. Look at that. All right, so let's change the upper one to small, and we have the medium down here. All right, and then all we need to do now is creating the last case, which is 3 small ones in a row. And what we can actually do is copy the definitions here for the two constants and copy it one more time. And then we use small again 3 times. I could have copied those ones, but that's how it is sometimes. All right, and then we can use obstacle 1 and its position, CG point, X and Y. And what we need to do here is using the obstacle 1 divided by 2, obstacle 1 size.width, divide that by 2 because of the anchor, and add 50 again. So we have obstacle 1 and position dot y for the y position. Then we can copy that one. Let's do that twice. Obstacle 2, obstacle 3, and then in that case we have to, this is the right one, so let me maybe comment that left, right, and this is going to be the center one. So let's let's just remove that piece of code here, and again let's use self.size.width and subtract the obstacle 2 size.width divided by 2 and subtract 50, just as we did with this one right here. And the center one is actually the easiest, so let's use simply self size width divided by 2. All right, so now let's add movement to every obstacle. Let's copy 2 here, save time wherever we can, so let's add 3 here, and then again add those children, copy it 1 time, and there we go. All right, so now we have created all of the row types that we actually need to. And what we can do now to test that, let's move back to gamescene.swift, and we can simply choose whatever we like. So let's use a 3 small obstacles in one row. Let's see what happens. And there we go. This looks good. What else do we have? Let's use 2 medium-sized obstacles. So what's that? There is as we can see here, they are somehow shifted to the right side. So let's have a look at our medium-sized ones here. 2 medium. And as you can see, I just forgot to divide that by 2 right here. So let's try that again. And then we should see the correct result. And there we go. And let's choose another one. Let's use 2 small ones just to be sure that this works. And they are shifted to the right. So let's see what's wrong there. Oh, and there we have the reversed problem. Actually, we should remove that one. This divided by 2 here, since we want them to be a little more centered. So let's have a look. Yeah, much better. So now that we have this in place, let's think about how we can actually randomly create those obstacles and add them to the screen and also let them move down. And to do exactly that, we will move back to game scene and create a special function for that, which we will call add random row. And this random row, for this random row, we need a random number, which we will generate as an integer by using arg for random uniform, and simply pass along the number of values that we want. And we actually want 6 different values from 0 to 5, and to get that we will simply enter 6 here, and then we can switch through this random number, and we will then this time we use default, and we will have a case for 0. I have to break here. and for 1, 2, 3, 4, and 5. So 5, 4, 3, 2, 1. And all we need to do now is call our add row function, and then we can simply use the row type and add 0 here. And we have to unwrap this. And then we'll copy. Well, what's the problem here? Oh, I have to enter raw value here. So, and by entering that, we will simply pass along the different row types depending on our random number. So let me just paste that everywhere here, and then we have 1, 2, 3, 4, and 5. The only question that remains now is where do we actually call add random row and when? And actually there is this pretty nice update function that is already created for us by the template. And what we want to do here is we will use this update function to repeatedly call our add random row function in predefined intervals. So let's create some properties here. First of all, last update time interval, and this is ns time interval, and also another variable property last yield time interval for the last time we actually created a row, so ns time interval. And now within the update function, let me give us some more space here. It's pretty dense, so this is a lot better. For this update function, we will create another helper function which we'll call update with time since last update. And this will receive a parameter time since last update, which is a CF time interval. All right, and what we want to do here is we want to use the last yield time interval and simply add the time since last update, and then we check if our last yield time interval is greater than 0.6. Then what we want to do is reset the time last yield time interval. Let's set this to 0, and here we will call add random row. And now to actually call the update with time since last interval, we will use now the update function, and we create another variable which is time since last update, which is the current time that we gather as a parameter in the update function, and we'll simply subtract last update time interval. And then we will check if the, first of all, let's use last update time interval and set this to the current time. But now what we can do is we check if the time since the last update is greater than 1, so more than a second has passed since the last update. Then we will use time since last update, set this to 1 divided by 60, and let's then use last updates time interval equals current time. All right, so with that set up, we can now call update time update with time since last update and pass along time since last update. All right, and now if this works, we should be able to see a lot of different row types. So here we go, and this works really good. Very nice. So now our game actually works pretty much perfectly. All we need to think about now is how to test if our players hit the obstacles, and we need to implement the 3D touch feature. So so that we can stay in the simulator for a little longer, let's first of all implement the contact test. And this is actually a pretty simple contact test in our case. We have already implemented the or assigned the SK Physics contact delegate as a protocol to our game scene class. So all we need to do now is implement the delegate method, which is did begin contact. And all we need to ask is if contact and its body A and its node and this name is equal to player, then what we want to do is game over. And then we can later show some game over scene, but we will deal with that later. For now, let's simply see if this works. And let's have a look at the simulator. And as soon as we hit the second bar, we have game over. Game over, game over, game over. And this looks pretty good. So to move on now with our game, we need to think about how we can actually get the pressure on the iPhone screen. Again, this only works if you have a iPhone 6s or 6s Plus, because these are the only devices that support 3D touch. And so that we can actually work with that, what we need to implement is the touches move delegate method of the SK scene class. Let's just do that right above the move to view so that it stays on the top. And we will simply use the touches moved function right here. And then we need to get this touch. So let's create an if-let statement here and get the touches first object. So this is a set. And from that we use the first object. And from that touch, we can get the maximum possible force. And we can then use the touch and access the maximum possible force property here. And then we can get the force, so touch.force. And what we actually want to work with is the so-called normalized force. So let's create that normalized force because we want to work with that as a coefficient later. And we simply get that by taking the force and divide that by the maximum possible force, so that we get a nice coefficient that we can work with. And then we will simply use the players. So let's use player 1 and the X position. And then we will use the normalized force in a second. So let's create, first of all, self.size.width. Divide that by 2. And from that, we want to subtract the normalized force times self.size.width divided by 2. And then we will subtract little of the edges so that our players do not leave the screen really. And this is actually what we need to do for our player 1. Let's do the same thing for the player 2. And all we need to do here is instead of minus, we add a plus sign here, since the player 2 moves to the right and the player 1 moves to the left. And that's actually all there is to do for this to work. We need to implement one more delegate method, which is the touches ended, because we want to reset our players, and therefore we will, let's write another function reset player position. And what this does is it simply takes the player and sets it to the initial player position. That's what we use this property for. So initial player position, and we will now call this method here reset player position. And to actually test that, let's now bring this to a real device. So here we are. This is what our game looks right now. And if I touch the surface, you can see that it already moves. And if I press quickly and firmly, it moves directly to the edges. And we nicely aligned those players by setting good values in our calculation. And I can move them around pretty nicely and control that also very good. All right. So actually all that there is left to do now for our game is to add some music. What we also need to do is to end the game once we collide with something. And we should always also prohibit this game from moving around in different directions. So let's do all of that right now. And as you've seen, this works really good. So I'm going to move back to the simulator. First things first, we will simply deactivate the device orientations for landscape left and right so that only portrait stays active. And for our game over scene, let's simply create a new game scene. Let's call it game over scene. It's going to be SK, an SK scene. So let's simply add that, and we have to import Sprite Kit here, Sprite Kit, and then what we need to initialize this here. First of all, we need the init with coder, call super init with a decoder, and this is required. And then we can define our own init with size. So we have super init with size and pass along the size. And then let's say self background color, UI color, let's use SK color, black color. Let's create a message which is going to be game over. Let's create a label, SK label node, with a font. Let's choose Optima Extra Black. This is the one I chose. And then we will simply use our label, assign our message as text property. Let's use SK color, white color here, and let's position it right in the center. So CG point, self size width divided by 2, and self.size.height divided by 2, so that we can center our label. We could also increase the font size, but let's keep it that way, and we will simply add our child here, which is the label. And of course we have to override this this init function, and then all there is left to do is implement the touches begin function, so that when we touch our game over screen, then we can go back to our real game scene. So let's create a transition here, transition, just an SK transition. Let's say fade with duration 0.5 seconds. Let's create a game scene, which is our game scene, and initialize it with self.size. And then we'll simply call self.view present scene, the game scene with our transition. And we will do something similar in our game scene. So as soon as our where's our contact test? So here we will show, as soon as we have game over here, we will call another function, show game over, and we will call this function right here, show game over. And what we want to do here is, again, create a transition, which is an SK transition, fade with duration 0.5 seconds. Let's call this game over scene, just the game over scene. Initialize it with self.size, and then again self.view present scene, which is the game over scene with our transition. And this is all there is to do. So let's run the application again in the simulator, and then we can see if we reach the game over screen pretty quickly. So if we reach that bar, we should see game over. We click again, and here we are. And with that done, actually our game is completed, but we also have some fun little background music that I'd like to show you how to implement. So you will get this with the tutorial files on GitHub. So just have a look at that. this is a simple loop that we can include into our project. I will drag it right into our project. We should select copy items if needed and add to targets. And to add this music to our game, we can switch back to game view controller. And in addition to importing UI Kit and Sprite Kit, what we should do is import AV Foundation for our video player, and then we will have to define a new property, which is the background music player. So background music player, which is going to be an AV audio player. And right here, when we create our game scene within the view controller, we can create our player. So let's first of all get the URL. So background music URL using the NS bundle, main bundle, and then simply use URL for resource with a name and an extension. So it's called BG Music. The extension is MP3. So this is our background music URL, and then we have to do try background music player equals AV audio player. We need to check if this works, because this can throw an error, as you can see here. Contents of URL, so background music URL, which we have to unwrap because it's an NSURL object, and if something does not work, we can print an error like can't play music. All right, and if we did that, let's just build that real quickly and see if this works, and it does. And then we can configure our background music player with the number of loops. If we set this to -1 or -1, it repeats infinitely. And then let's call prepare to play, and last but not least, music player dot play. And if we run our application, we should actually be able to hear it. If I run the app with QuickTime, we can't actually hear something, and there we go. And game over. So I hope you had fun with this. We created a game that won an Apple Design Award, not with that nice of a design, but the principle is the same, in a little under an hour. So have fun with it, have fun playing it, and I hope that you will register for the Swift Tutorial Conference. It should be absolutely amazing, and don't forget to tell me what you'd like to see on the conference, and I'll see you next week.